Looking at number rules and nonlinear graphs. So we'll look at this dot pattern, and in term 1 there is 1 dot, in term 2 there are 4, in term 3 there are 9 dots, in term 4 there are 16 dots, and this pattern actually could keep going infinitely. So what we'll do now is come up with a rule for this pattern so that we could predict how many dots would be in term 55 or term 60 or term 1 million without actually having to draw the pattern out. So to get the rule, we'll start by creating a data table. Now at the top row I'll put the terms, so there's term 1, 2, 3 and 4, and I'm going to call the terms T, and the bottom row will be the number of dots in each term, D. So in term 1 there was 1, in term 2 there was 4, in term 3 there was 9, and in term 4 there was 16. Now the rule for this pattern is the number of dots, D, equals the term squared. And I can check in both the table and the pattern. 1 squared is 1, 2 squared is 4, 3 squared is 9, and again I can add that up by looking in my pattern. So it's actually a 3 by 3 square and a 4 by 4 square. So the rule is the number of dots equals the term squared. So if I wanted to work out the 6th term, the number of dots, so I would say T is 6, so 6 squared is 36. So in the 6th term, the number of dots would be 36. So I can now graph my pattern, and I have a coordinates table up the top, and the T is the X, the term is the X coordinate, and the number of dots is the Y coordinate. So I can write down my coordinate list to plot. So I've got 1, 1, 2, 4, 3, 9, 4, 16, 5, 25, and 6, 36. Remembering that we always write the X coordinate first and the Y coordinate second. Obviously you don't need to write out the coordinates every time, you can just use the coordinate table and we can plot those points. So we have 1, 1, and then we have 2, 4, and then we have 3, 9, we have 4, 16, we have 5, 25, we have 6, 36. And we can connect those points. And you can actually see that our line is a curved line, and that's because it's exponential. So it's growing at an increasing rate. It's not linear, it's not going up by the same amount every time.